Okay, this is going to be a video reviewing Unit 2, Topic 1, Quadratics. So our first two problems ask us to solve the equations algebraically and then to graph the original equation on our calculator to determine which solution is extraneous. So to get rid of the square root, the first thing I'm going to do is square both sides. And that's going to leave me with x plus 20 equals x squared. Now I'm going to bring everything over to the right side because x plus 20 has no power and x squared has an exponent, and it's easier to work if I have a positive leading coefficient. So I'm going to subtract x. And then I'm going to get 20 equals, well, I have no like terms here. This one has an exponent. This one does not. So this is going to be x squared minus x. Now I'm going to subtract the 20. And again, I don't have any like terms because this is a constant. It has no x. This is x squared. This one's x. So it's going to be 0 equals x squared minus x minus 20. So now I want to think, do I know of two numbers that add to -1 and multiply to -20? And I do. I know that -5 and +4 multiply to -20 and add to -1. So now I'm going to set each one equal to 0. I'm gonna add 5. I get x equals 5 and x equals -4. And so now what I'm gonna do is I'm going to type them on my calculator. So you see I've typed it here, and I'm gonna press graph. And I see that these graphs intersect. It appears that they intersect at 5. But if I want to double check, I can go to my table. And you can see -4, there it is, right? That's not a solution because that says 4, that says -4. So that's not going to work. I don't get the same y value. But if I scroll down to 5, I get the same y value. So 5 is our solution, and this is extraneous. So for number 2, why don't you pause the video since we walked through number 1 and see if you can do number 2 on your own. Okay, so you should have worked on number 2 on your own, and if we square both sides, we get 2x plus 15 equals x squared. Subtract 2x. I'm actually going to do 2 steps at once here. I'm going to subtract 2x and 15 at the same time. You do it one step at a time if you're more comfortable with that. And I get 0 equals x squared minus 2x minus 15. And my two numbers that add to -2 and multiply to 15 are -5. And, oh my god, I bet this one's going to be 5 also. And +3. And I set those equal to 0. And I solve. Add 5, add 5. I get x equals 5 minus 3 minus 3. X equals -3. That's so funny. I bet it's going to be 5 again. Let's see. Y equals, and I'm going to just change this to 2x plus 15. And there's, let's see, here's 5. Yep. And again, if I check it, I see 5. So this one is going to be my solution, and this one is extraneous. All right, so solve using a graph on your calculator. Make a sketch of your graph, state the solution, and then write a sentence explaining how you got the solution. So let's go and get these graphed. So I'm going to put y, I'm going to clear this out, 4x. And then this is x minus 3. And here is my graph. Make a little sketch. Just make a real quick one. And so I'm looking for this point. It looks like it's going to be at about 9. Let's see. So yep, 9, 6. So I'm going to say, so state the solution. The solution is x equals 9. I know the solution is x equals 9 because the graphs intersect at the point 9, 6. That's good. All right, so now let's take a look at the second one. Oops, must have leaned on the calculator. So again, pause the video if you did the first one with me and try the second one on your own. Okay, you should have tried this one on your own. And you're unpausing the video to check your work. And I've got a graph. This one kind of starts back here. This one kind of goes down. Oh, and there it is, 4, 3, because these are the same. So my solution is x equals 4. And I'm going to write a similar sentence. I know the solution is x equals 4 because, well, I spelled because wrong. There it goes. They intersect at, oh, lead problems. 4, 3. All right. So now we are going to work in factored and vertex form. So I'm first asked to write this equation in factored form. So I'm going to take two numbers that add to 2, -2, and multiply to -8. So that's going to be -4 and +2. All right. Well, as soon as I do that, I know what my x-intercepts are, because if I have my factors, I know my x-intercepts. Because if I set this equal to 0, I would get 4 and -2. So I'm just going to put those on my graph. 4, oops. 4, oh, that was -2, duh, and -2. So write the equation in vertex form. This is a little trickier. So now what I'm going to do is I'm going to add 8 to both sides. And I've got f of x plus 8 equals, and you leave a little space, equals x squared minus 2x. All right, so now I'm going to take the -2 on my calculator or in my head. I'm going to divide that by 2 and square it. So, like, if you need to use your calculator, just use your calculator. There is no shame. And I get 1. And I'm going to add 1 to both sides. Plus 1, plus, stupid pencil. Plus 1. All right, so now I'm going to add 9 plus 1, and I've got f of x plus 9 equals, and now I'm going to factor this. It's going to be x minus 1 squared, because -1 and -1 add to -2 and multiply to 1. The last thing I'm going to do is I'm going to subtract 9 from both sides. And vertex form is going to be f of x equals x minus 1 squared minus 9. And now I know my vertex is the opposite of what I see out inside. So it's going to be +1 and -9. So +1, -9. And now let's type it in. And it doesn't matter what form you type in. I'm just going to type in standard form because it's a little easier. So I've got x squared minus 2x minus 8, and I'm going to go look at my table and just verify. Yep, 4, 0, that's 1 x-intercept. I can see my vertex because I can see the symmetry of the graph, 0 at 1, -9. I see it's symmetrical. The numbers are the same on both sides. And while I'm in my table, I also can get this y-intercept that I'm asked for, because at 0, when x is 0, the y value is -8. So I'll add that in. And I'm just going to add one more point to -8. And I can get a really nice parabola. Okay, so number 6 is a lot like number 5, so why don't you pause the video and try number 6. Okay, if you are rejoining me, let's take a look. Factored form is going to be f of x equals x plus 5, x minus 1, because 5 and -1 add to 4 and multiply to -5. So that immediately tells me my x-intercepts are 1 and -5. To write it in vertex form, I'm going to start by adding 5 to both sides. I'm going to take the 4, I'm going to divide it by 2, and I'm going to square it. 4 divided by 2 is 2, squared is 4. So now I've got, oh, I'll get another 9, that's a bonus. plus 9. And now this factors to x plus 2 squared. And for my last step, I'm going to subtract the 9. And vertex form is f of x equals x plus 2 squared minus 9. The opposite of what's inside and exactly what's outside. So I've got negative 2, negative 9. All right, so let me get this stuff graphed. 1, negative 2, negative 9, and negative 1, 2, 3, 4. The other x-intercept. And when I type this in, plus 4x minus 5. Go look at my table. 0, negative 5 is my y-intercept. And again, if you need to look at your table for some points, that's good. Get some points here. There's my y-intercept. Here's one more. And here's our graph. Okay. So now we are moving into some complex number operations. I'm going to quickly do, I'm gonna do out a couple of them slowly, and then the rest of them I'm gonna kind of do a little faster because they get a little repetitive. I'm gonna do number 7 slowly. I'm gonna notice that 3 is a real number and 6 is a real number. So I'm going to add those together and I get 9. I've got 4i is an imaginary number and negative 2i is an imaginary number, and if I add those together, I get 2i. When I go to number 8, I've got a subtraction problem. So the first thing I'm going to do is recopy the first number, and then I'm going to distribute the negative to the second. So instead of minus parentheses 3 minus 5i, I'm going to say minus 3, and then negative negative becomes plus 5i. Once I've done that, I'm going to do the same thing I did in number 7. I'm going to put my real numbers together, and then I'm going to put my imaginary numbers together. Okay. Number 9 is a multiplication problem. I'm going to do this one using the box method. I'll do another one using FOIL in a minute. So I'm going to set up my box. I'm going to put negative 2 plus I on the top and 3 minus 4i on the side. Now I'm going to multiply. 3 times negative 2 is negative 6. 3 times I is 3i. Negative 4 times negative 2, I'm sorry, negative 4i times negative 2 is positive 8i. And then negative 4 times I is negative 4i squared. Now I want to pause at this moment because I need to remember that 4i squared is like negative 4 times negative 1 because I is the square root of negative 1. But and so that means I squared has to be negative 1. So now this 4i squared really is just 4. I'm sorry, negative 4i squared is really just 4. So I'm going to put my real numbers together. Negative 6 plus 4 is negative 2. And then 8i plus 3i is 11i. Right. I'm going to do one more multiplication problem slowly, and I'm going to do number 11 because it's a little different because it's 3 plus 2i and it's squared. And we want to remember that that's like 3 plus 2i times itself. So I want to make sure I write it out and not just square each term. So this one I'm going to do using the FOIL method. So first, 3 times 3 is 9. Then 3 times 2i is 6i. Then 2i times 3 is also 6i. 2i times 2i is 4i squared. And again, here I had negative 4i squared and that became positive 4. Here I have positive 4i squared. Well, if I squared is negative 1, this is going to become negative 4. So 9 minus 4, put my real numbers together, and then put my imaginary numbers together. All right, the remaining 5 are just another subtraction, addition, multiplication, subtraction, and multiplication problem. So why don't you pause the video and then I will reveal the answers for you. So number 10 is 19 minus 8i. This one is going to be negative 7 plus 7i. While I'm subtracting, I'm going to do this one also, and then I'll get to the multiplication ones. Okay, so now the multiplication ones. This one I'll do with the box. And then the plus 9i squared, I want to remember that's minus 9. So I get 7 minus 24i. Then I'm going to do this one with FOIL. I've got negative 18 minus 21i plus 30i plus 35i squared. And of course, this is going to become negative 35. And so then negative 35 minus 18 is negative 53. Yeah, negative 53. And plus 9i. All right, so now we've got a whole page of solving quadratics over the set of complex numbers. So I'm going to do some of them long and slowly, and some of them I'm going to move a little faster once we get a little repetitive. So number 16, and I want to remember that I'm not, unlike the last test, I'm not told what method to use. I can use any method I want. So for this first one, obviously I'm just going to take the square root of both sides. And I'm going to get x equals plus or minus the square root of negative 49. Well, because this is negative 49, it's like the square root of 49 times the square root of negative 1. So I get x equals plus or minus 7i. Now for number 17, I noticed that it doesn't have like a plain x term, like number 18 has a plain x term. Number 17 doesn't. So it just makes sense to solve with square roots again. So I'm going to subtract 20. I get 2x squared equals negative 20. Divide by 2. I don't know why I put a negative there. I get x squared equals negative 10. I get x equals plus or minus the square root of negative 10, which obviously I'm now going to rewrite with an I. And it's just going to be I root 10. Okay, number 18 does not have it's not going to be one I just take square roots with. It is, however, in standard form, so that's a bonus. I don't want to factor it because there's this 4 here. This 4 here actually tells me I'm going straight to the quadratic formula, which, if you need to write that down, again, is pencil x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so write that down somewhere if you need it, and here we go. For number 18, A is 4, B is 11, C is 9. Nice positive numbers. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I've got x equals negative 11. And 2 times 4 is 8. That's easy. Now I'm going to grab my calculator. And 11 squared minus 4 times 9 is negative 23. So at this point, the problem is almost done. All I have to do is take out the I. I've got negative 11 plus or minus I root 23 over 8. And that is done. All right, so number 19 is not in standard form, so I'm going to start by subtracting 3x. And I'm going to line up my like terms, and I've got x squared plus 5x plus 6. And I'm pretty sure I can factor this one. Like, this is a 1, that's nice. What adds to 5 and multiplies 6? Oh, that's easy peasy. X plus 3, x plus 2, 2 plus 5, or 2 plus 3 is 5, 2 times 3 is 6. I get x equals negative 3 and negative 2. Whammo. All right, when I get to number 20, this is going to be another square roots problem because it's kind of set up with those parentheses. I remember that from the beginning of the unit. I'm going to start by dividing by 3. I get x plus 4 squared equals 9. Now when I take the square root, I get x plus 4 equals plus or minus 3. I'm going to now separate this to two equations. X plus 4 equals 3. X plus 4 equals negative 3. If I subtract 4 from the first, I get x equals negative 1. If I subtract 4 here, I get x equals negative 7. Alrighty, number 21 is not written in standard form. So I got to get it in standard form like number 18, it needs to equal 0. So I'm going to subtract 2. And when I do that, I'm going to line up my like terms. So I end up with 1/2 x squared minus 3x plus 6 equals 0. All right, so now, I got a quadratic formula. I don't really have a choice because that 1/2 is tricky. So here's my quadratic formula. Here is A, B, and C. So x equals negative, b, be careful because the b is already negative, so negative, negative. I know my singing is so good. Plus or minus the square root of b squared. Be careful because you don't want to get stung by the negative sign. Put it in parentheses. Minus 4 times a times c, 6, all over 2a, which is kind of nice because 2 times 1/2, that's not so bad. All right, so here we go. Negative 3 is just 3. Plus or minus the square root, now it's calculator time, and watch how I type it in. Negative 3 in parentheses squared minus 4 times a, just 1/2, times c, and I get negative 3. Now 2a, when I do 2 times 1/2, oh, that was all about 2 times 1/2. I just get 1. So I don't really need to write dividing by 1. You can if you want, but I'm not going to. So the last thing I need to do is just deal with this little negative sign. And just like we did up here, the negative 23 became I root 23. My answer here is going to be 3 plus or minus I root 3. All right, 3 more. We'll just do them together. Although you should pause the video, I guess, really. When I mean do them together, I mean I'm going to do them out. Number 22 has no x term, kind of like number 17 had no x term. So number 17 I did with square roots, number 22, square roots. So let's subtract 2, and I get x squared equals negative 232. That's a big number. Is that a perfect square? Now, obviously, I know I can't do this because I'll get the scary error. Scary error! But let's see if this is... No, that's scary. So let's just go with x equals plus or minus the square root and a negative 232. X equals plus or minus I root 230. The end. All right, number 23 is not in standard form, just like these guys. I gotta move it. And I wanna move it so everything that is alike stays lined up. And I'm gonna have x squared minus 9x minus 22 equals 0. So this is an odd number, but I wonder if there is something that adds to negative 9 that multiplies to negative 22. Yep. All right, last one, number 24 on this page. I am not in standard form, and I want to be really careful. I'm going to subtract 3x, and I'm going to make sure to line up my like terms. Then I'm going to subtract 2, and again, I want to make sure I line up my like terms. So now in standard form, I've got x squared plus 4x plus 9 equals 0. There is nothing that adds to 4 that multiplies to 9. So I have a choice. I can complete the square, or I can use the quadratic formula. I have already used the quadratic formula twice, so I am going to complete the square. So I'm going to move the constant. Subtract the 9. B over 2 squared would be 4, so I'm going to add 4 to both sides. I've got x plus 2 squared equals negative 5. When I take the square root of both sides, it's negative 5, so I'm going to have x plus 2 equals plus or minus. Now I know this is I root 5 because it's negative, and then I just need to subtract 2 from both sides. Now, if you did the quadratic formula, you get something slightly different. If you did the quadratic formula, you would have x equals negative 4 plus or minus. Now let's see, what b, so here's our standard form. So if we did b squared minus 4 times a times c, I would have negative 20. So it would be I root 20 all over 2a, was just 2. So if you did the quadratic formula, you get a slightly different answer, so either one of these is acceptable. This is just not reduced, and that's okay with us. All right, our last problems are asking us to graph these functions on our calculator and decide how many zeros, roots, x-intercepts it has, provide a sketch and a complete sentence. So we've got x squared plus 4x plus 4. When we graph that, here is the graph, and I can see that it just kind of skims the x-axis, and I don't even care where. I just need to know how many roots. So this function has one real zero, root, x-intercept, whatever you want to say, because when I look at the graph, it crosses the x-axis once. All right. So now I'm going to go x squared plus 2x minus 3. And I've got a graph that looks like this. This function has 2 real roots, zeros, x-intercepts, whatever, because it crosses the x-axis twice. Ooh, that's a terrible W. All right, and now the last one. Oh, that does not cross the x-axis at all. Oh, I missed. Whatever. That's good enough for me. It just has to be a sketch, because I don't really care where the vertex is. All I care about is how many roots it has. If it doesn't cross the x-axis at all, it only has complex zeros. So this function has 2 complex zeros and no real zeros because it doesn't cross the x. I can't spell. X-axis.